And finally, without further ado, we are ready for today's keynote interview. I'm super excited to be speaking with Ya Xu, Head of Data Science at LinkedIn. Let's get Ya up and jump right into the interview.
Good morning.
Good morning.
Good morning, everyone.
I am super excited to have this opportunity to chat with you. Thank you for joining us, and for LinkedIn. LinkedIn has been a huge supporter of the podcast over the years, and we're very appreciative of that.
Thank you for inviting me. And I know TWiML for many years as well. I know that a lot of folks from my team actually has been showing up on your podcast. So it's a great honor to join you here today.
Awesome. So let's jump right in. I think this interview is going to be particularly interesting because earlier in your career, you were on the platform and infrastructure side of things, the topic that we're focused on here. But now you're the head of a large data science team. Tell us a little bit about your background and your journey.
Sure. Maybe I'll go a little further back in my journey. And I started out with, many years ago that I got my PhD in statistics from Stanford. So during my time there, I certainly, for those of you who may be familiar with the statistics PhD program, it's quite theoretical in general. But Stanford also has a very strong track in the applied approach onto statistical problems too. So that's where I essentially spent a lot of my research on sort of the how do we apply statistical modeling to solve some of the real world problems, and did my thesis in semi-supervised learning on graphs. Back then, semi-supervised learning wasn't that popular relative to today. And the reason I'm sharing that is also because, if I'm thinking about my passion and what I like to do in my career, is always about, even though that I was doing platform earlier in my career, like it's always this internal drive of wanting to solve some real problems. And so that fast forward to my time, I went into industry for my PhD days, worked at Microsoft for a few years, and then joined LinkedIn. And I've been at LinkedIn for about 8 years now. It's kind of crazy how fast the time flies. And so in my early days, both when I was at Microsoft and at LinkedIn, I was an individual contributor, very much focusing on building platforms and enable tooling to solve, to enable many other folks in the company to be able to utilize, and either that'll be directly applying it in the business and the products that they're in, like to kind of creating that leverage across the board. So then and that's what I spent most of my career on so far. And about 4 years ago, was when I decided that I wanted to learn how to manage a team. And I was very fortunate to be supported in that career journey and transformation by my boss, who is the chief data officer at LinkedIn, and also obviously many other leadership at LinkedIn. So then I stepped into more on, I guess, the what you call application side of the world of, but certainly still very much working very closely with the folks who are building the platforms, and maybe a little bit more at the customer side. But also at the same time, I do have folks on my team who are working hand in hand with the platform teams and from the science angle to make sure that we have the right methodology, we have the right approach on how our platforms are enabling and solving the problems that we see.
Awesome. Speaking of those problems, I suspect everyone who is watching us is familiar with LinkedIn, and perhaps even some of the ways that LinkedIn uses machine learning, especially if they've caught some of our previous interviews with LinkedIn folks. But what are the specific types of problems that your teams are focused on?
So for those of you who are, I'm glad that a lot of you are familiar with LinkedIn, but maybe not everyone is familiar with how LinkedIn is organized. So my team is the global central data science team. So what that means is, there is really only one data science team at LinkedIn. But the way that we operate is that we actually work very closely with various different functions and areas across the company, right? So, if you think about a company has various functions that's either, deliver and develop product that the folks can think about, if you use LinkedIn's app or if you go to linkedin.com on the web, that's what our product is, right? So I have folks in the team who is working embedded with various different areas of our product. Either that is feed, that is messaging, that is search, that is jobs, and careers, all these aspects of our product. I also have folks who are very closely working with our go-to-market teams. And this is particularly our marketing teams, our sales team, thinking about how we can use machine learning, statistics to actually optimize our go-to-market motion as well. A simple example would be, as marketing team, like who should they target? How should they optimally spend their marketing money, right? As our sales team, which are the customers that our sales team should really talk to? And like which customers are more likely to churn so that they can actually engage with them more closely, right? So there's a lot of things that we do. And then on top of it, we also work on with infrastructure teams too, right? Thinking about if you have a lot of Hadoop jobs, how do you optimally schedule those jobs such that you can avoid the peak time and you can optimally utilizing your offline resources, both in terms of memory and storage, right? So there is just an array of problems that the team solves. And then going to what I mentioned earlier is this, I also have folks who are focusing on more horizontally, again, thinking about enabling, right? So folks who are focusing on developing experimentation methodology, folks who are focusing on differential privacy that we can chat more later as well, like folks who are more focusing on anomaly detection, algorithms, forecasting, things that is more horizontally enabling various different applications that is happening, again, in the various different areas that I mentioned earlier.
Mm-hmm. Mm-hmm. You mentioned that your team is centralized, but also embedded. This is the organization as a topic that's come up quite a bit at the conference, and every organization kind of finds a different place on the spectrum. But often I see that at a certain level of size or scale of a data science team, it tends more towards a distributed model because, the different businesses want to have their own data science resources. Tell us about the choice to maintain the centralized embedded model, and what works there, what doesn't work, and how you think about that generally.
That's a great question, and you're spot on. If you only have 5 data scientists, and it's certainly the right decision is to centralize them, because you actually are able to offer them a career growth. You offer them a peer group that they can talk with, and all of that. And when the team gets really, really big, I know that there are certain companies out there that has maybe, I don't know, close to 1,000 data scientists across the company. I think then you definitely get into the situation where you have enough mass within each of the business unit that you can have maybe not a global centralized data science team, but you kind of have the local sort of center of excellence within different units. So at LinkedIn, we're somewhere in between, right? In the sense that my team is about 350 people. So sizable, but also at the same time, this goes into my experience on both the platform side and also the application side is, if you think about the benefit of having a team that it's in the central organization, the benefit is the leverage, right? It's that you can put, like, for example, I can put my weight behind what are the right tooling that we should be building for all data scientists. And so where my team is sitting, because we have a broad view across all different applications, we understand together, collectively, what are the needs that we have from both the algorithm standpoint, methodology standpoint, from the platform tooling standpoint, to be able to make every data scientist to be more successful, right? So you kind of have to establish. You have this allows us to establish that leverage across. But you can say, on the other hand, the downside of having a central team is the potential danger of, you have this central team, think that they are the center of excellence, sit in the corner, and not really actually try to figure out what are the problems that we're solving. Right? Like, think about this, right? I can come up with the best algorithm, the best approach, but I could be solving the wrong problem. Then what's the use of that in a company, right? Like, if you are solving the wrong problem. So I think I actually think the LinkedIn model works really well in the way that I have my team organized in the way that they are kind of like in their unit, and then they work very much embedded with each of the product area or the business area they're working at, right? So they pretty much, you can think about them as in one foot in the domain area they're working at, and one foot with the rest of the data science teams. So they are solving problems that is really business critical, but also at the same time, they get to enjoy the benefit of that knowledge sharing, that leverage, and like sort of that strategic approach in how we are solving all these applications and problems as well.
Mm-hmm. Having been on both sides of the fence relative to platforms and infrastructure and application side of things, what do you think makes for a successful working model between those two different teams? Where do you draw the line between one and two? It sounds like you have some horizontal capability within your team. And how do you generally think of that aspect of organizing your team's work?
That's such a great question. So first of all, I want to say that I've seen many failures in that working model. Like, not as in like, oh, this is disastrous and like, the whole company failed because of that. But you can definitely, even today, I still see in pockets of examples that I think made that working model not working, right? So let me kind of be explicit. So the way that I've seen on both sides of the aisle is folks on the application side, right? They complain about problems, right? They're like, okay, this is not working. It's not able to, allow me to do X, Y, and Z, right? And they kind of then threw that problem over the wall to the platform team, and the platform team like catch it. They either are just doing exactly what the applications team tell them to do, right? For example, I need you to build it in this way so that I can use it, right? Like, so they either are taking orders from the application team and not thinking about, is that the right architecture? Is this only solving your problem? Are there things down the road that this makes this not like a long-term solution, right? They either do that, or they're like, who are you to talk to me? I'm going to take orders from you, right? Like, I'm going to just do my thing because that's what I care about the most, right? So I've seen those two extreme examples play out in reality. Even
the way you're describing it sounds like a delicate balance. Like, you want some pushback, but not, neither of these extremes.
Absolutely. So the part that I always I like, I'm gonna quote on one of the sort of legendary engineering leader at LinkedIn, that he used to say, like, do you want to be part of the problem or do you want to be part of the solution, right? And the thing is that a lot of times the application team think that it's the platform's job to build the solution, and it's a platform's job to make them successful in using those tools and the capabilities. And the thing is that it has to be very much hand in hand. So let me kind of break it down, right? Like, you think about there's various different stages as you are building a platform. And in day one, like as you're building that capability, is to have accountability on both sides, right? I would always go to my team and say, hey, you know what? It's not just the platform's job to deliver the feature you need. If the feature is end up delivered and you're like, you know what, that's not the right feature that's going to solve my problem because I have all other problems, I'm not going to be able to use that platform. I said, hey, you know what? It's as much of your responsibility as much as their responsibility as it is yours, right? So I'm going to hold both of you accountable to make this successful. So I think from day one, that just really forces the teams to think about it together as they have the same goal, the same success, right? Like that both sides have. And then so once this sort of maybe a MVP is built, and you get into this sort of adoption phase, right? This is, a lot of times the platform team has these challenges. They build something, they think it's amazing, the world's wonderful, like the most wonderful thing in the world. And then like the folks are like, I've got something here that kind of worked for me. Why would I want to like migrate all my approach to yours? Right? I have to, like, people just have that intrinsically unwillingness to go move into something new, even though that the new thing long term may be beneficial for them. So the way that I also see that's worked really well is having this model that I like to call champion model. So let's say, for example, you build a platform and you have to convince 10 other teams to use it, right? Don't say, hey, like, all of you guys come and use my thing, but start with a couple of them who are already leaning in, right? They are like already showed interest. They already are like, you know what? Like, I'm actually excited about this thing. So get them on board first, right? Because they are the customers who are more likely to be telling you what's going wrong, and they're not going to abandon you right before, like, just because there is a simple bug that you have in your system. Like, so work with them to address really their need, and also allows your platform resources to be able to focus on making them happy, right? So once you have get team A fully onboarded and happy using your platform, you go to team B, you go to team C, and once you have like I don't know, 4 out of the 10 teams onboarded, and they started to demonstrate the value of using your platform, boom, you know what? The rest of the 6 teams will just fall in line. So I think, again, in the adoption phase, there is also that sort of approach, and that needs to be think very carefully as well. And I would say then the last phase, we talk about during the building phase, during the adoption phase, and then in the mature phase, right? So let's say you've already got a platform that is running, everybody's using it, and obviously we all know that you have to continuously evolving and building on top of it, right? Like, and then like just creating that holistic culture, that like the application team, they should be like they should demand the platform teams, not as in like, and again, another mistake that I've seen people make is like, oh, the platform is not able to solve my problem, so I'm gonna build myself something else. And I think engineers, this is engineers like it's not the greatest unless it's built by me, right? Like, I think this is in general what we all have is like, mine is the greatest. So creating that culture on the application side to really demand the platform to be able to solve the problems with them. So I think that's one. And also on the application side is having this model, what we call like SME, right? Like the subject matter experts. So thinking about, the individuals who are expert at using those platforms, and they become sort of this local champion for platforms in their team, right? So imagine that you build a platform that in a team of 20 people, if you have one person who is an expert of using it, then the other individuals on your team can go to that person to learn how to use it. At the same time, if they have any feature request, it's actually much easier to go through that person, the SME, because the SME understands the platform capability. So they're not just gonna ask any random feature, right? They're gonna ask feature that really matters to the team, right? So that, like, you know, the platform is also much easier for them to take those feature asks and then work with the SME to figure out what's the right solution to evolve the platform. So I think, you know, I say it a lot, but I do think it really takes both sides of the coin to make this happen really well. And then one last thing I would say is also just from architecture standpoint, like from platform architecture standpoint, always think about how to build a platform in an extensible way, right? You wanted to democratize as much as you can. Like, you know, if you have a platform, a team of 10 that's building this tool, like you have 500 people who are using it. And think about how you can give them, those 500 people, a chance to contribute to your platform. The more that you can design your architecture in that way, the better it gets.
What are some ways that the platforms at LinkedIn support this?
Oh, we actually, I want to say many of our platforms do that. Like, I know that you are quite familiar with our ProML, and like the platform, and you can actually build your modules on top of it. You can, like a simple example is my team actually developed this model, like explainability capability, and then so they used it in their application. That went really well, and they just kind of built it as an extensive module on the platform, so other people who wanted to use it, they can use it too, right? Another example is our, you know, we have a platform for anomaly detection and forecasting. So you think about there can be use cases where the existing algorithms that we built into the platforms were not enough to detect a particular anomaly. So we actually, again, allow the application teams to then introduce their own algorithms on top of it, right? So there's always that, you know, the platform is focused on the core, but if the platform is architected in a way that allows that extensibility, then you got all the 500 other people who is going to be working for free for you to make the platform better, right? Versus they decided, you know what, the platform is not able to solve my problem. Let me build my own.
Yeah. I want to take a second to remind folks, if you're watching via the home tab on the conference platform, make sure you click into the streams tab so you have access to the chat. And I welcome you to ask any questions in the chat, and I'll work them into the conversation. Before jumping into questions and continuing the interview, I just wanted to observe that a lot of what you described about the relationship between the platform team and the application team would equally apply between your team and the business team that you serve, but just from the other direction. Do you apply the same kind of philosophy in that relationship?
Yeah, that's a really good meta observation. Absolutely. I think the part that I've always seen of organizations, how to help organization to be successful is again, for them to feel like they are really not working against each other. They are working towards the same goal, right? Once the folks really internalize, our goal is the same, is to make this successful, then like everything just fall together. So I agree. I think that's a really good observation.
Interesting question on this topic from Thomas in the in Q&A about avoiding quote unquote hero syndrome. You talked about kind of engineers always wanting to build it themselves. That's maybe related to this idea of hero syndrome, but the team that kind of wants to be the team to build the platform. And LinkedIn's maybe a little bit beyond this because you've got established teams that own platform. But have you seen early on where, you know, a new technology or idea comes around and different teams are kind of vying to be the one who builds and owns the official thing?
I would say that first of all, I think it's was it Tom who was Thomas made that comment. I feel very strongly agree with you that like you're avoiding the hero syndrome. And there was once I heard somebody saying that in terms of which kind of talent they hire when they interview, what matters the most to them. That was like a startup founder, and his comment is like, I'm looking for somebody who has a high IQ over ego ratio. so the fact that and I think sometimes ego can really get in the way of the broader picture. So at LinkedIn, maybe in the really early days when LinkedIn was kind of going through a growth pain, when we had multiple data teams in various different parts of the company, right? Like I was literally like, I'm gonna take just one sentence to describe LinkedIn a little bit. So organizationally, LinkedIn is functionally organized, right? So we have engineering team that reports to head of engineering. We have product reporting to head of product. We have the finance team report to our CFO, and then all of them then report up to the CEO. And back then, I remember that when I first joined LinkedIn 8 years ago, we literally had a data team in engineering, which I am in part, and then we also have a data team that is reporting to product. We also have a data team that reports into our CFO. So you can kind of see that. Sure, I think in the early days, it took a lot more effort to align, making sure that we avoid that hero syndrome, and then actually all come together and building the right things all together. But I think nowadays it's simpler, it's easier, just because also the company is getting a lot more mature and from organizational standpoint as well.
Mm-hmm. Let's talk about some of the specific areas that your team operates and kind of has built out capability. One of those is experimentation. Can you talk a little bit about experimentation, why it's so important at LinkedIn, and some of the things that you've done there?
Absolutely. So experimentation, I know sometimes that term gets used in various different ways, but I think that here you're particularly referring to sort of this randomized controlled experiment, like A/B testing. That's also kind of another common term that people use. So why is it important? I'm actually gonna first use a story, and to especially, I know a lot of folks in the audience are ML engineers. You develop a lot of models, and when I first joined LinkedIn almost 8 years ago, and like a couple months after I joined the company, there was I was pulled into this discussion. And at the time, LinkedIn, just a little backdrop, we didn't really have an experimentation platform. Running experiment was a little bit of spotty, depending on who you are, whether you wanted to do it or not. Then you kind of, so it wasn't a common practice in terms of our product development at all at the time. And so I was put into this discussion. The discussion was that there was a experiment that was run on launching a new machine learning model 8 years ago. LinkedIn wasn't that sophisticated when it comes to using machine learning in product development yet. So think about, the bar was low, and then you got that model that was launched that was amazing, right? You looking at the numbers coming from experiments, it was just shockingly, amazingly good result. Mm-hmm. And so the team went ahead and launched it. And so back then LinkedIn was still a independent, well, it's still a standalone company. We were not part of Microsoft. So all these people watching those very closely, because that if you have a 10% lift on revenue, that's huge in terms of what translates into our financial numbers, and then that goes into our stock price and all of that, right? And so our finance team came, and then they're looking at it wait a minute, you launched this thing, but I'm watching the numbers in terms of our revenue, but I did not see a tick. I did not see in my time series, I did not see that there is a gain in our numbers. That's not real. That's not real. So what we had to do was we actually had to ramp down that experiment. Literally, think about, you got this wonderful feature. We have to ramp it down, reverse it, to actually then we saw in that time, boom, you can have a drop, right? To actually make everybody believe this is actually a great thing that we are launching, that we're building. So so now think about fast forward to today. LinkedIn, we at every single given time, we have about 500 experiments that's running. And that ranges not just from our algorithm and improvements, but also is pretty much every single product launch, every single change that we're making, we actually have it go through A/B test, because that's the way that we understand how our members, how our users are actually reacting and to the changes we're making. Do they like it? Do they not like it? Right? And for every single launch, we monitor like effectively like over 1,000 metrics, just so that we get a sense as much as we could of how is this a good feature or is this a bad feature. But not only that, internally, as in our process, it's like we are using those, every team are taking the results from their experiments and as the accounting of how much they have contributed, right? Like so it really, think about that, like going from 8 years ago where we were for that one launch to today. It's a drastic improvement. But like the benefit to the company is tremendous, right? Because think about over the years, why did we decide to invest more in ML? Right? It's because we realized, wait a minute, like it was a really good investment when we actually are focusing developing those algorithms that is actually able to bring a lot of upside to the business. So that translates into the right investment to the company, for the company. And at the same time, there is also this culture that, again, going back to Thomas's question on this heroism, right? I think maybe I was a bit too harsh on ourselves. Like, I think heroism is everywhere. Like, we would have this maybe two product managers who are both thinking, my idea of building this product is better, right? Like, so they, like, nowadays, instead of arguing with each other, intuition against intuition, like, you know what, the conversation become very simple, right? Why don't I just test it? Right? If I test it and it tells me that it's a better thing, or maybe it tells me that my intuition is wrong, I will learn something, right? So it kind of really intrinsically changed this culture of maybe this heroism culture to this learning culture, to this really data informed culture. So that was a long answer to your question.
No, you mentioned something in there that was really interesting, that you measure the contribution of folks on your team based on their results from this experimentation platform. And if I'm understanding you correctly, it makes a ton of sense. If you don't want to measure folks just based on kind of model results in a vacuum, because who knows what those actually result in production. But then in production, if a model's in production for a long period of time, you've got all other kind of models and things happening on the site that are impacting the long-term impact. And so tying their performance to the results in the experimentation platform is an interesting way to kind of isolate the impact of that one model. Is that the idea?
Yeah. So first of all, maybe just make a small correction. I don't mean as in, hey, when we are evaluating an engineer, like, okay, how much like metrics did you gain? Like in that sense, like, I mean, that I think a lot of time is thinking about in terms of the team, in terms of the area. Like we have a goal, we have a target, and that target, let's say, is to improve metrics X by 5%. And then, like, whether this whole team, when I say team, I actually more like area. We talk about how LinkedIn is cross-functionally collaborating together to achieve that 5%. But did this line of business achieve that 5% gain on that metric? Like, we do keep a very close eye on, like, and then that is measured against the experiments, right? Like, we add up all the gains that we have from various different experiments that we have to see, do we hit that goal? But in terms of individual the performance, there's a lot more that goes into.
There's a ton of issues there. The point was more that the experiment is an interesting way to isolate the real life impact of a model in a way that it's hard to do, without exposing it to the real world. And once it's exposed to the real world for a long period of time, there are other factors that make it hard to isolate that particular model's impact.
Definitely. And I always think about when we're building models, we have our utility function objective, and then you train your model, you really try to optimize that. And we do our offline replay also to see, hey, is this model actually, we think that it's going to improve CTR? Is it actually going to be improving CTR? But all these are just, I like to think about this as in like, my boss used to say, like, intent versus impact, right? So your intent when you're building the model is to optimize towards that objective function, right? But did they really, right? That's where experimentation comes in, because that is actually measuring the real impact of what your algorithm is doing.
Mm-hmm. Another area that LinkedIn has invested quite a bit in is privacy, in particular differential privacy. Can you maybe give us an overview of your team's work in that area?
Certainly, I think it should not be a surprise to everyone here that privacy is very, very important, and I believe it's actually one of the biggest disruption that we will have. Disruption always presents challenges and opportunity at the same time. But like thinking about from the regulation standpoint, which is the bare minimum that we hopefully forces many of us to start thinking about this area more seriously, like GDPR, CCPA, even thinking about Apple's IDFA, right? Like all this. This is sort of where it's not about if anymore, right? It's about really when. And obviously from consumer standpoint, it's a super important area as well. And for those of you who are intrinsically very driven by solving really challenging problems technology-wise, like this is really also just an area that has tons of opportunities. So going back to your question regarding my team's work on differential privacy, I want to first maybe motivate a little bit, because when we talk about privacy or data privacy, it's a massive area, right? Like, and you think about this is always, it's interesting of a tussle between even just the term data and privacy, right? Data, think about what data does. We use data. We extract information from data. That's what data is for to data scientists and to ML folks. And then you got privacy. Privacy is really about how to prevent sharing information, right? Like, so you got both, you wanted to extract information, you got the other pool that you wanted to actually stop sharing information. So it's kind of that interesting tussle between the two. And we talk about, like, you can introduce privacy by to some extent, right? Think about a lot of what GDPR is doing. Say, hey, this PI information, like we should anonymize it, right? And then you got a lot of this algorithm that's there as well, right? Like k-anonymity, like all this that is able to do certain level or different levels of anonymization, but that's not enough, right? Because if you think about there's stats from research several years ago that among a U.S. population, like 87% of U.S. population, if you know their birthday, zip code, and I think the other one is like a gender. I think it's birthday, gender, and zip code. Then you will be able to know who they are. Like, you're gonna pin down who they are. So that just says how challenging it is to do privacy well. So coming back to like differential privacy, it's really has become a more of a gold standard for how we preserve privacy in data. The concept of differential privacy is very simple, right? So what it really says at a high level, right, is what you can learn from the data should be the same with or without a single person's information as part of it, right? So think about if you are learning a distribution from a huge data set, right? And let's say you learned about a distribution, it's a curve, right? And then you take one member or one user's information out of that data set. And then you learn that you use the same algorithm, you learned the another curve. These two curves should be very, very close to each other, right? So this is where what we call should be the difference should be epsilon, right? Should be very small. I had to throw the epsilon number there. So that's what and then so if you can, that's differential privacy guarantee. So if you have an algorithm that is able to meet that criteria, it's guaranteed to have differential privacy. And it's, then I'm not going to go into a lot of theoretical details, but then it comes with a lot of benefits. You can do the additive and all of this, right? So we have very heavily invested into and both. Ultimately, we wanted to apply differential privacy in the way that we use data across the board. We actually have introduced it in our ads reporting. And think about the reports that we give to our advertisers that we apply differential privacy on top of it. When we share our data externally to public, for example, what are the companies that are hiring? What are the skills that's trending? All this, we actually also apply differential privacy before we share the data externally, just so that we can really make sure that we put our members and customer first, and then so that there's no chance and that their information would be leaked or would be under this sort of there's a bunch of attacks that people can do to back engineer the individual information, and under differential privacy, this just guarantees that there's no such a way, that there's no such risk.
Mm-hmm. Mm-hmm. And so do you think the differential privacy is kind of ready for prime time for the, I don't know, average company? I mean, LinkedIn has been at the front of this and has spent a lot of time working on it. How ready do you think it is for kind of general consumption? And in particular, there's differential privacy and differentially private machine learning, which is a whole other set of challenges.
Yeah, that's a great question. I want to say, I want to say it is ready. I'm going to be bold on that one, right? So first of all, we all know Census. Actually, Census is using differential privacy now. So if Census is using it, I think everyone else should be using it. And on top of it, I do also think that there are a lot of open sourced capabilities that's out there already. That Microsoft has this big open source differential privacy solutions out there. I think Google also has some. So even if you don't have expertise in your own company to develop your own algorithm, you can still get started by using the ones that's already open sourced, right? So I do think that I would encourage everyone to start getting to this field. And on the other hand, are there challenges of building those solutions and applying those solutions? Yeah, absolutely. I have to say, one challenge that we see, very practical challenge, is how do you think about we talk about this difference between the two curves. You learn the epsilon, how do you choose it, right? How do you choose epsilon? Because that is going to indicate the trade-off between the utility and the privacy, right? That you who's going to decide on choose what's the right epsilon for your company, for your application, right? So that's a very practical challenge that the company has to face. The second one is also a lot of when people think about differential privacy, they think about, okay, you got data, you add a bunch of noise to it. And then you can, forget about the rest, right? Everybody knows how to add noise. It's to data. That's
the easy part.
It's the easy part. It's the easy part. You can choose a Laplace noise. You can choose Gaussian noise. You can just all this. But the hard part is actually depends on the application, depends on the query. Different differential privacy algorithms, even though that they could all meet the differential privacy criteria. So they are all differentially private algorithms. but they can actually have a different information loss in the process, right? So let's say, for example, you have a query. If you apply the noise at the very initial step, top of the funnel, right? So when you go through this whole query, what you get is there's very little information. So if you turn a data into white noise, then there's no point of having that data to begin with, right? So the challenge of differential privacy is also there needs that sort of this expertise especially in some applications, to come up with the right algorithms that you can actually preserve privacy, but also preserve the utility of the data itself as well.
Yeah, for more on this, I'd refer folks to the interview that I did. The interview was just over a year ago at NeurIPS in Vancouver with Ryan Rogers at LinkedIn on the way that differential privacy was applied to this problem that you call the top K problem.
Yeah.
And we go into a ton of detail there. In our last few minutes, I'd love to hear about some of the tools that and platforms that kind of give your team leverage at LinkedIn.
Well, I hope I made it bluntly obvious that I'm a big fan of platforms in general. And so, we have actually a sister team that to me that they really focus on building a lot of the data platforms. And for, again, not just my team, right? Like thinking about like the rest of the company as well. So I would say a few of them that has been super critical. One, I've already mentioned about experimentation platform, right? Because that's really the easier that you make experimentation process to be, the more people is going to be using it, and then the more data driven that the company will be, and then that would have a cascading impact in how we are investing as a company and the kind of people that you attract and all of that, right? So I think the experimentation platform. And second of all is certainly our machine learning platform. A platform that is able to both thinking about how if I think about any field, how fast different fields has evolved over the past few years. Like machine learning area is definitely, that's like literally you got every day you open up a research journal, you will see something new that some people has developed that works better than what happened yesterday. So thinking about the platform is building a way that is able to be extensible, that is able to evolve with the industry, with the field. So super critical that as well. And again, also, how do you seamlessly transition between online and offline? So a lot of really good problems in that space, and certainly my team uses that as well. And the other platform I would say is our like a platform that devoted to metadata and search and discovery, right? So thinking about, you have a lot of various different data constructs or data assets, right? And like a metric is a data construct, a model is a data construct, just any data set is a data construct, a feature that goes into the model is a data construct. And when you start to be really very data focused as a company, and you got all these data constructs and data assets that lies around, and how can you make sure that they can be leveraged by many people? How can you make sure that, if there are issues on them, that we actually have a way to identify them? Like, so having this almost like a catalog of all these data assets in the core of many other applications is really, really important as well.
Keynote you're referring to?
It's Data Hub. We call it Data Hub.
Data Hub? Okay.
Yeah, and then so like you can also think about like how does all these data constructs relate to each other, right? One big challenge that I'm sure for a lot of the data developers here is like, you got a data, maybe that fits into your model or fits into some other things that you're doing. You have no idea where the data come from, right? And then over time, this data may deteriorate. This data may change because of 5 steps ahead, like like in the chain, in the lineage, that it's creating that problem. So having, again, like a tool, a platform that is able to providing that lineage, just really, I cannot say, I cannot understate how important that is. And then we also have platform that is able to help us do anomaly detection, forecasting, and root cause analysis as well, right? When something goes wrong with the data, like what caused it? And then why, I mean, first of all, to be able to detect it, we know, for example, like models, like features can have a distribution shift for many reasons. I could have a bug in my product, all of a sudden the telemetry, the tracking is off, and that fits into my model automatically, and then the model turned out to be not performing anymore. Like being able to monitor at every step of the funnel is also obviously very important to model development, to matrix development, all of that as well. And then so since you mentioned Pinot, I'm also gonna I'll touch on that one as well. So Pinot is our sort of a distributed OLAP storage that we have developed ourselves at LinkedIn and open sourced several years ago. That is really able to provide scale of, think about the scale of data that we operate at LinkedIn. Like that is able to allow us to be able to both serve online use cases. For example, if you go to LinkedIn on the site, a lot of the analytics that's on the page are powered by Pinot in the backend, and it allows us to do internally able to do our OLAP on it as well. So super powerful. And we talk about differential privacy. We also are able to build a meteor on top of Pinot so that we can have all the use cases that's already in Pinot that then be able to easily onboard into the differential privacy capability as well.
Awesome. Well, we've covered a ton of ground in this conversation, but it's time to wrap up. Yeah, thanks so much for joining us this morning and sharing a bit about what you and your team are up to at LinkedIn.
Thank you so much for having me, and I really enjoyed that conversation.
Same here. Thanks, Ya.